Alright, doing this problem called insert interval. You are given an array of non-overlapping intervals where interval of I equals to start and represent the start and end of the ith interval, and intervals is sorted in ascending order by start of I. All of this is given already. You're also given an interval new interval start and it represents the start and end of another interval. Insert new interval into intervals such that intervals are still sorted in ascending order by start I and intervals still does not have any overlapping intervals. Return intervals after the insertion. Interesting. Given a of non-overlapping intervals, which is already sorted and everything. Do I have to do a binary search to find where this interval will go? Really? Is it a binary search? But yeah, I could do a binary search to find, but then for insert, I have to anyway shift, right? So, what's the point? Could I just do a linear search then? And how would that work? Well, you keep adding the interval one by one into a new list, and and then you uh, when adding every time you check this interval with the new interval. Okay, till there is no conflict. Uh, if there is a conflict, then you merge, right? Okay, I'm getting some sense of it. Let's look at an example, and I'll show to the whiteboard for the example. So the example given in the problem is you're given the intervals as 1, 3, and 6, 9. They're all non-overlapping. Now I don't know whether they consider the equal interval like and start matching is overlapping or not. That's not clear to me, but we'll see. Uh, it's not matching anything specifically, but okay. So 1369 and what we are given is 2 comma 5. So what we do is we start with 1 3 and we first check whether 1 3 overlaps or intersects with 2 5, and it does. So if it does, then you already have to merge. So you merge and you put 1 5 into the final list. Okay, and 1 5 and 6 9 don't overlap. So when you get 6 9, you do 6 9. But for 6 9 you don't have to check. So maybe another thing you have to do is maintain a flag that checks have added new interval. hmm But after having added new interval, there is a problem. What is that problem? That you have to then check the last guy because earlier they weren't non-overlapping, but now they might overlap, right? For example, if it was 2 8, right? Then what you would do is you'll make it 1 8, and you'll say, yeah, I added, but then now you can't write 6 9 because 6 9 now non-overlapping, right? So then you have to fix these two and make them 1 9. And this could very well be 2 2000, and might encompass all the other non-overlapping ones. Fair enough. So, so for every new interval, there's another thing. It could be that this also is non-overlapping. So meaning that I have like 1 2, and I have 100, and this guy is like 5, 6. So it will just fit here. Yes, it will. What's the question? I mean, what I really want to do is like in this previous note, like just merge intervals. I'll go through that, and but before that, I insert it somewhere. So one bad way is, okay, insert it at the end, sort, and then merge. But why would you sort? Why would you do and log, and that would be just stupid, right? Yeah, don't sort again. It's already sorted. So the only thing is, okay, because it is a array. Um, if it was a linked list of integers, then I would have, even then it's a problem. Okay, basically shifting is a problem. You can always do binary search to find the starting point. But okay, so the only thing is we get the sense of it. We just have to check um, the exact algorithm. Otherwise, essentially, you just insert and merge, right? And so the cases that you're considering, one is this case where it does not overlap at all, but it has to be fit in. So you definitely maintain two flags, right? One, there's at least one flag which tells that, hey, uh, have considered new interval, right? Or have added new interval. Once that is done, after that is that all the future uh, elements intervals that I pick in, I just have to merge them, right? And so before this flag is set, what I have to do, let's check that. So before this flag is set, there are two cases. One is this will completely non-overlap with this, in which case you just keep on adding, right? And other is you keep comparing this guy with this guy. So there will be two cases. One is either three cases. So yeah, there are three cases. One is the interval that I'm now taking, which is this. Either 5 has to come completely before it, then that's fine. So that's one case. So okay, so there's this is the interval I'm checking, and this is the interval, new interval. So that's one case. Other is, say, this is the interval I'm checking, and it intersects. Now it can intersect anywhere. So it can intersect like this, it can intersect like this, it can intersect like this. Doesn't matter. Different ways, but there is some intersection. And the last bit is, which is what we don't have to care about, which is the new interval is somewhere far down the line. That is something we don't care about. If it's completely beforehand, it's easy to check, and we can add that. These cases, in all these cases, what's happening is the so in this case, uh, start is less. So that is one definite case. That start is less. Actually, if the start is less or and is less, one of them has to be lesser than what. So it's basically this is a case. So any case other than this and this. So that means not of this and this. So not of and 2 less than start 1, not this, and not I got it right. So that, yeah, general sense is clear. Now let's come to the code and solve it. Okay, so one thing I'm maintaining is a boolean flag called have added new interval, and initialize it to false. Then what you do is okay, for each you also keep a list of integer equals to new array list for each interval in intervals. Two things to check. One is if not have added new interval. If we haven't added new interval, then all you have to do is just check whether. So one case is if the interval that you are considering, which is interval, if the and so if new interval of 1 is less than interval of start, then what you have to do is you do list dot add new interval, and then you do also do list dot add interval, and you also say, hey, this flag is now true. Right. And other case is if this is completely far out. So if interval of 0 is greater than, sorry, if new interval of 0 what am I doing? Is greater than interval of 1, then just simply add interval and move on. And other cases, then they have to conflict, right? They have to conflict. And so in that case, what you want to do is take the smallest and the largest. So just add a new interval with the values as math.min of interval of 0 and new interval of 0 and math.max of interval of 1, new interval of 1, right? And when you do that, you also say, hey, you know what? I have added new interval. And by the way, in this case, all other guys will just get added without any problem. But otherwise, okay, this is the if, and then the else. Else means the last guy is already added. So now you have to always compare. There are two things here. One is if the and the easy else. So this is again conflicting. So conflicting means if interval of start is less than or equal to conflict list dot cat list dot size minus one, and you get this, and this guy's end. If your start is less than this guy's end, then they should do something. Otherwise, you just add. Otherwise, you just do list dot add interval. But if that's not the case, then you do list dot cat list dot size minus one. Okay. That is all. And at the end of all those shenanigans, you return the list dot to array and something like this. Fix the compilation errors, don't get any. Run example test cases. Run example test cases. And submit. You get a wrong answer. For the case when one of the list is when your list is empty, your output is also empty, but you expected 5-7. It's a fair game. Which you can handle by doing at the end here. I mean, you could, but okay, if I mean, you could do whatever, right? You could do fair enough. I'll do that, whatever. So I'll keep the sanity of the flag. Submit. And it works. All right.